The last section in Chapter 8 deals with absolute values, equalities, inequalities, but I guess first it's a good idea to review what an absolute value is. So the absolute value notation looks like this, and it says that the value that you get is either 0 or greater than 0. So if you take the absolute value of -2, really what the question is saying is how far from 0 are you on the number line? So here's 0, here's -2. I'm 2 units to the left, regardless of whether I'm traveling left or right. So the absolute value of -2 is 2. Oddly enough, the absolute value of 2 is also 2, because that time you're 2 units to the right of 0 on a number line. So the question really is, how far away from 0 are you? Doesn't matter whether it's left or right. So the first question says, what does it mean to solve the absolute value of x is less than 3? Well, in terms of values on the number line, that means you're 3 units away from 0. So certainly 3 is one of the answers, right? Here you are, 3 units away from 0. But I'll bet you it works in the other direction too. What if you went 3 units this way? You would land here at -3. So this value and that value are both positions that are 3 units away from 0. So I can get an x value of 3. I can get an x value of -3. There's 2 solutions. I can also write my answer like this. X equals plus minus 3, and that indicates that there's 2 answers. X equals 3 and x equals -3. So what if we get an equation like the second one? 4x plus 3 absolute value equals 11. Well, are there one solution or 2 solutions to that? Let's pull up this board here so I don't run out of space. So I have the absolute value of 4x plus 3 equals 11. Well, what's inside this set of brackets here could be 11, or it could be -11, right? Because both 11 and -11, when I take the absolute value, gives me back 11. So 4x plus 3 could be 11, or 4x plus 3 could be -11, and now I have to solve both of those equations. All right, so I subtract a 3 from both sides. I get 4x is equal to 8. Divide both sides by 4, and x equals 2. And we can try it. 4 times 2 is 8 plus 3. That gives me 11, and sure enough, the absolute value of 11 is 11. All right, let's try the other side. Subtract a 3 from both sides, and so we get 4x equals -11 minus 3 is -14. Then we divide both sides by 4. Simplify that, and we end up with -7/2. See if that works. 4 times -7/2 plus 3. So that gives me -14 plus 3, -11, and yes, the absolute value of -11 is 11. So I end up with 2 answers. One of them is x equals 2. The other one is x equals -7/2. Because what's inside that absolute value bracket could be 11, in which case 4x plus 3 is 11, or it could be -11, and that's why I set up both the possibilities, and I come up with 2 separate answers. All right, look at the one underneath that. It says, what happens if the absolute value of 2x plus 7 is equal to 0? Well, we had said that we end up with plus minus whatever number is on the right-hand side, except there is no plus minus 0. So here's a case where I only have to solve 2x plus 7 equals 0, because it can't be -0. All right, subtract the 7 from both sides. I get 2x is -7. Divide both sides by 2, and we get x equals -7/2. And if I put -7/2 back in there for x, I'll end up with -7 plus 7, which is 0. So sometimes I'll only get one solution, and that happens if that absolute value is equal to 0. Look at the last one. The last one says the absolute value of 3x plus 19 is equal to -2. Before you start solving this, check and see if that question makes sense. Remember we said that the absolute values are either 0 or greater than 0. So here you're saying that the absolute value of something is a negative number. That's not possible. No solution. Right? The absolute value of any number cannot be negative. All right, what do these graphs look like? What does the graph of an absolute value function look like? It says make a table of values and graph f of x equals the absolute value of x. So let's do that down here. We'll put a couple of negatives, 0, and a couple of positives. Nice and easy. The absolute value of negative 3 is 3. The absolute value of negative 2 is 2. The absolute value of negative 1 is 1. So far, it looks pretty easy, right? Negative 3, 3 is up here. Negative 2, 2 is over here. Negative 1, 1 is over there. And so it looks like a line that just keeps going, maybe down into that quadrant down here. We put a 0 in for x. We get a 0 out for y. That continues our trend. But now what happens? If I put a 1 in for x, I get a 1 out for y. Oh, 1, 1 is over here. 2, 2 is over there. 3, 3 is over there. So what happens is this thing turns a corner when it gets to 0. So over here, it's a line going that way. Over here, it's a line going that way. The graph of the absolute value function looks like a V. Now the question says use it to solve the absolute value of x is equal to 4. Well, I've just graphed the absolute value of x. The only thing left that I have to do is graph y equals 4. Here's y equals 4. Graph my horizontal line. So do you notice that it intersects, the red and the green lines intersect here and there. So once here at 4 and once here at negative 4. You also begin to realize maybe why the examples we did on the last slide worked the way they did. When we graphed the absolute value equal to 0, we just graphed a horizontal line right on top of the x-axis, so it only intersected that graph once. When we were trying to graph that negative one, like let's say I asked you to solve the absolute value of x is equal to negative 2, you'd be trying to find out when that red graph intersects y equals negative 2, and it never does. So that absolute value function is either 0 or greater, and it will never intersect a negative number. So where do those two intersect? They don't. All right, so we got a couple of examples here to solve. Let's take a look at the first one. The first one is 6 times the absolute value of x. Minus 7 equals 5. So this one, we're going to start by adding a 7 to both sides. 6 times the absolute value of x is equal to 12. We'll divide both sides by 6. Absolute value of x is equal to 2. So what values can I take an absolute value of and get 2? I could do that for x equals 2 and for x equals negative 2. So the absolute value of 2 is 2. The absolute value of negative 2 is also 2. All right, look at the second one. For the second one, this is one of those cases where we're trying to make the inside equal to 9 or negative 9. So either x plus 4 equals 9, because the absolute value of 9 is 9, or x plus 4 equals negative 9. So nice and easy, subtract a 4 from both sides, and I get x equals 5. Over here, subtract a 4 from both sides, and I get x equals negative 13. So those are the two values of x that will work. Put them back in. One will give you 9, one will give you negative 9, but the absolute value is still 9. Number 3 is only kind of interesting because it's got fractions in it. Still solves the same way. X over 3 minus 2 equals 1, or x over 3 minus 2 equals negative 1. So in both cases, we'll add a 2 to both sides. We'll get x over 3 equals 3. And then to clear out that 3 on the bottom, we're going to multiply both sides by 3. So here we get x equals 9. Try it out. 9 divided by 3 is 3. 3 minus 2 is 1. Over here, same process, obviously a little different numbers. 2 minus 1 is 1. And then when we multiply both sides by 3, we get x equals 3. So 3 over 3 is 1. 1 minus 2 is negative 1, but the absolute value of negative 1 is 1. All right. Do they get a little bit more complicated? Sometimes. Take a look at number 4. See if we can make any sense of number 4. First thing I'd do is I'd move a 9 over to the other side, try to get the absolute value brackets by itself. So I get the absolute value of 2x plus 3 equals negative 5. Oh, that's a quick end to my problem. Because 2x plus 3, the absolute value can never be negative 5. We're going to end up with a V-shaped graph up here and a negative graph down there, and we'll never have an intersection between the two. Right. Number 5 has a couple of extra steps to it. So the first step is to move that 15 over to the other side. So we get 2 times the absolute value of x minus 1 equals 5. Divide through by 2. And so we get an absolute value of x minus 1 equals 5 halves. And so either x minus 1 equals 5 halves, or what's on the inside, that x minus 1 equals negative 5 halves. Because when I take the absolute value, either way I'll get back 5 halves. And so in both cases, we're going to add a 1 to both sides. When I add a 1 to the right-hand side, I'm going to add that 1 as 2 halves. So that I have 5 halves plus 2 halves, right? 1 is the same thing as 2 halves. So I get 7 halves. Over here, if I add a 1 to both sides, again, let's add a 2 halves as my 1. 2 minus 5 is negative 3. So negative 3 halves is my other one. Number 6 is the one that's a little bit long, right? It says absolute value of 5x plus 9 equals the absolute value of x plus 4. So it could very well be that they're both positive, that 5x plus 9 is positive and x plus 4 is positive. Or it could be that one of them is positive and one of them is negative. And so really there's only 2 different things that I have to look at. I don't have to look at like 4 different cases, but I have to look at the 5x plus 9 being positive and the 5x plus 9 being negative. So let's pull that over on different boards so we have enough space to work. All right, so we were given the absolute value of 5x plus 9 equals the absolute value of x plus 4. So my one option is that 5x plus 9 is equal to x plus 4. My other option is that 5x plus 9 is equal to the opposite of x plus 4. Now you realize it's possible that x plus 4 could equal the opposite of 5x plus 9, but I've already taken care of that here. Because if I just flip the negative signs over to the other side, I'll get the same thing, right? It's like multiplying by negative 1. So let's tackle the first one first. 2 steps, get rid of a 9 from both sides, and I get 5x equals x minus 5, and then subtract an x from both sides. So I get 4x equals negative 5. When I divide by 4, I get x equals negative 5/4. The other side, if I've got a 5x plus 9 equals negative x plus 4, that means that 5x plus 9 equals negative x minus 4. And then same process. Subtract a 9 from both sides, and I get 5x equals negative x minus 13, right? Negative 9 minus 4 is negative 13. And this time we're going to add an x to both sides. So I get 6x equals negative 13. Divide both sides by 6. And now the big moment, do they work? All right. So it's going to take a little bit of effort to check our work, but it's probably a good illustration. So if I put in an x equals negative 5/4, I get 5 times negative 5/4 plus 9. So negative 25/4 plus 9 is 36/4. Gives me 11/4. On the other side, negative 5/4 plus 4, which is 16/4, gives me 11/4 right away. So these to both equal positive 11/4, I've got an answer that works. All right, so now let's check the x equals negative 13/6. All right, a little bit more of a pain to put it in. 5x plus 9. So 5x plus 9, so that gives me a negative 65/6. 9 is the same thing as 54/6, right? 6 times 9 is 54. When I add them together, I get a negative 11/6. On the other side, if I do negative 13/6 plus 4, 4 is 24/6. 24 minus 13 is 11. Remember, these things are in absolute values. So is the absolute value of negative 11/6 equal to the absolute value of 11/6? Yes, it is. So both of those answers work. Negative 5/4 works. Negative 13/6 works. All right, so what's left? What's left are inequalities. So we've done absolute value equalities. Let's look at absolute value inequalities. The first question says, what does it mean to say the absolute value of x is less than 2? Again, in terms of distance on a number line, we're saying that the distance between 0 and 2 is less than 2. So it includes numbers like this, right? But also includes numbers over here. So think about the possibilities that I can put in. I can put in a 1, right? The absolute value of 1 is less than or equal to 2. The absolute value of negative 1 is less than or equal to 2. The absolute value of negative 1.9 is still less than or equal to 2 because that's a 1.9. 1.9 is less than 2. So the values that will work are values between negative 2 and 2. Those are the values for which the absolute value of x is less than 2. Put another way, I could write it like this. Negative 2 is less than or equal to x is less than or equal to 2. So if I have something like this, the absolute value of x is less than or equal to 2, that means put the negative on the other side. Now, how about the absolute value of x is greater than or equal to 2? If it's greater than or equal to 2, then the distance between 0 and that point on the number line is more than 2. So we're talking about values that are over here and going on forever, and then values that are here and going on forever. So for that one, I'm going to say x values that are greater than or equal to 2, or x values that are less than or equal to negative 2. That's what it means when it's greater than. So a less than or equal to is an and situation. A greater than or equal to is an or situation. So I could write this in interval notation by saying numbers from negative infinity to negative 2 joined with x values that are between 2 and infinity. So now what if instead of having an x, we had a 2x plus 3 on the inside? This is an and situation. Look, I've got that less than sign, so I want values that are between negative 5 and 5. So I want values from negative 5 less than 2x plus 3 less than 5. So in other words, I'm saying 2x plus 3 is greater than negative 5 and 2x plus 3 is less than 5, and I want values that meet both criteria. We're going to solve this like we solved that compound inequality that we had done earlier. We're going to subtract a 3 from everything. So I get a negative 8 over here and a 2 over there, and then divide through by 2. Negative 8 divided by 2 is negative 4. 2 divided by 2 is 1. And my answer says that x values between negative 4 and positive 1 will make that statement true. Don't put in a 1, right? 2 plus 3 is 5. That's not less than 5. That's equal to 5. Put in a value like 0 and it works. 3 is less than 5. So anything between negative 4 and 1 will work for this one. All right, here's the 3 different cases that I'm going to run into. And then I think on the next slide I explain how to find the ones. For the first one, that's not an inequality, that's an equality. So the first one is the case where I take that 3 minus 4x and set it equal to both cases. So I set 3 minus 4x equal to 5, or 3 minus 4x equal to negative 5, because inside that absolute value bracket could be a 5 or a negative 5. The second one is a less than, so it's an and situation. And means I can squeeze it between the positive and the negative. So negative 5 is less than 3 minus 4x is less than 5. The third one is greater than, and so it's or. So it's 3 minus 4x is greater than the positive, or 3 minus 4x is less than the negative. Because you realize that's what we did in this middle one over here. If we had the absolute value was greater than or equal to 2, we made it greater than the positive or less than the negative. That's what it means to be further away on the right and on the left. So greater than the positive, less than the negative. And we carry that same idea down to this one over here. So the last thing to do then is just to solve all of these. So let's see. Over here, we'll subtract a 3 from both sides. I get negative 4x equals 2. X equals negative 1/2, right? Negative 2/4. Over here, if I subtract a 3 from both sides, don't lose the negative. Negative 4x is negative 8. X equals 2. Right, for the one in the middle, I'm going to solve by using that compound inequality thing where I use 3 parts. Do the same thing to all 3. So the first thing I'll do is I'll get rid of a 3 from here, and from there. So negative 5 minus 3 is negative 8. There's negative 4x. There's 2. All right, we're going to divide by a negative. We haven't done this yet. All right, so we're going to divide by a negative. And when we do that, the signs all flip. Negative 8 divided by negative 4 is 2. That less than becomes a greater than. Negative 4x divided by negative 4 is x. That one becomes a greater than. Negative 1/2. Notice now the arrows are all pointing in the correct direction. If I hadn't flipped my signs, it would be weird. I'd be getting that negative 1/2 is bigger than 2, which is not correct. So if I want to write this in interval notation, the values go from negative 1/2 to positive 2. So when you divide by a negative, you got to flip the signs. We're going to run into the same thing over here. Right? When I subtract a 3 from both sides, I get negative 4x is greater than positive 2. Divide through by negative 4. When you divide by a negative, you flip the sign. So x is less than negative 1/2. Or, same thing here. We're going to subtract a 3 from everything. So we get negative 4x is less than negative 8. When you divide by a negative 4, you flip the sign. Greater than 2. Right, so I go from negative infinity to negative 1/2, and then pick up values on the other side from 2 to infinity. So this is sort of a summary of the 3 different types of inequalities you're going to see. You'll see the equality, you'll see the less than and the greater than. The equality means the inside is either plus or minus the number on the right. The less than is an and situation, so it's got to be between the negative and the positive. The greater than is an or situation, so greater than the positive or less than the negative. All right, if you want a little roadmap as to how these things work, this is how these things work. If it's a less than, then you've got an and situation, so you squeeze it in between here. If it's a greater than, then it's greater than the positive or less than the negative. And the last thing just says that, if you're doing greater than or equal to, less than or equal to, the same idea holds. You just replace those less thans and greater thans with the equality version. All right, what would you do if you had a case like this? I don't know, let's look at the second one. You notice both of these have fractions in them. The reality is you can get rid of those fractions pretty easily just by multiplying both sides through by 5 in this case. So multiply this side by 5, multiply that side by 5, and now you have the absolute value of x plus 3 is less than or equal to 60. Well, that's a case of it's got to be between negative 60 and 60. Because it's an and. Subtract a 3 from everything, so I get negative 63 is less than x, less than or equal to 57, and there's my answer. All right, last one. It says an engineer is designing a circular cover for a container. So maybe think of like the top of a garbage can or something like that. The diameter of the cover is to be 4.75 inches. All right, so a small garbage can. Must be accurate to within a half an inch, right? An absolute value inequality that gives an acceptable value for D. We call this thing tolerance. And so if you think about manufacturing, I don't know, I'm going to use my example of a garbage can. You've got the bottom of the garbage can, you've got the lid. There's going to be a little bit of variability every time you build that garbage can, but there's certain specifications. If that lid is a little bit too wide, you're going to put it on the garbage can and it's not going to hit those little snaps, and the first time the wind comes, it's just going to blow away. If it's too small, it's not going to cover the garbage can. It's not going to cover it entirely, and you won't be able to latch it either. Within, in this case, 5/100ths of an inch, then you'll still be able to latch it just fine. So when I make those garbage can lids, I've got to have a certain amount of accuracy, but there is a little bit of a give. So what if my garbage can lid was 4.78 inches? How would I know whether that's acceptable? Well, I would take the 4.78 and I would subtract the 4.75, and I would say, look, the answer is 0.03. It's within that 0.05 of an inch. What if the garbage can lid were 4.71 inches? 4.71 minus 4.75 is negative 0.04. But it doesn't matter to me whether it's above or below. It just matters that it's within 0.05 of an inch. So really what I'm looking for is the difference between the diameter of the cover and 4.75, but I'm looking for the absolute value. So I'm not looking to see whether it's above or below. I'm simply looking to see how far away it is. I want this value to be less than or equal to 0.05. Right? If that's true, then my garbage can lid will fit. If I have a diameter like 4.81, then that's too big, right? That's 0.06, and then my lid's just going to sit on my can and is not going to latch correctly, and it'll blow away. If that D value is 4.5, then I'm going to miss the top entirely. There's going to be a gap between the lid of that garbage can and the outside rim, and it's going to fall right in. So that's what we call tolerance. So that difference, it doesn't matter whether it's bigger or smaller, as long as it's within 0.05, everything fits correctly. And that's the end.